Hello viewers, in today's class we are going to discuss yet another important and conceptual definite integral involving the absolute value function and greatest integer function, right? So viewers, in mathematics the concept of function is very important, right? And once our concepts are clear with regard to the functions, then we can easily tackle the hard problems, right? So here we have to evaluate this integral, and here the limits are from -1 to 1 x, and here we have the absolute value of x divided by the greatest integer, that is x plus 2 square, right? So we have to find out the value of this definite integral. So let us start, and let us first call this integral as I, right? So here if we look at this integral, we see that here two important functions are involved. The first one is the mod function, and the second one is the greatest integer function. So what we will do, we'll take these two functions one by one, and we'll try to simplify this integral by making use of the definition of these two functions. So now let us first take the definition of mod function, right? So the mod function is defined as, that is, the modulus of x is defined as positive x whenever x is greater than 0, right? And this mod function is equal to 0 whenever x is 0, and mod x is equal to minus x whenever x is less than 0, right? Okay, so now we'll first use this definition to simplify this integral. And if we see the limits, here we have the lower limit as -1 and the upper limit as +1, right? And between -1 and 1 we have the integer 0, right? So this point, that is x is equal to 0, is the point where we will break this integral as a sum of two integrals, right? That is I1 plus I2, right? So when we take this interval, that is -1 to 0, then x is obviously less than 0, right? And when we take this interval, that is from 0 to 1, then all the values of x are greater than 0, right? So the mod of x is equal to minus x in this interval, that is from -1 to 0, right? This is -1 to 0. And when we take this interval from 0 to 1, then mod of x is equal to plus x, right? So now I1 and I2 are the two integrals. So I1 goes from -1 to 0, and I2 uh, goes from 0 to 1, right? So now here we'll have x, and then we have mod of x. So when we go from -1 to 0, then mod of x is equal to minus x. So here we have minus x, right? And in the denominator we can write the greatest integer of x plus 2 square, right? So we'll take care of this function in our later steps. And in the second integral we have x times the mod of x, and when we go from 0 to 1, then mod of x is equal to plus x, right? So here we have plus x, and here we have the greatest integer of x plus 2 square, right? So now we can write these two integrals as -1 to 0. Here we have x square and greatest integer x plus 2 square dx, and here we have 0 to 1, and here we have x square and greatest integer of x plus 2 square dx, right? Okay, so now we'll try to assign values to this function, that is greatest integer of x plus 2. Now let us see the first integral, that is I1, right? See here x varies from -1 to 0, right? So x varies from -1 to 0, and we have to assign a value to greatest integer of x plus 2 when x lies between -1 and 0, right? So what we need to do, we'll add 2 throughout this inequality, right? So what we will get, -1 plus 2, and here we have x plus 2, and then we have 0 plus 2, right? And now this inequality becomes 2 minus 1 is 1, and here we have x plus 2, and here we have 0 plus 2 is 2, right? So when x lies between -1 and 0, then x plus 2 lies between 1 and 2, right? And from the definition of greatest integer function, the value of greatest integer of x plus 2 is equal to 1, right? Because x plus 2 lies between 1 and 2. We can also verify it by taking some particular values of x plus 2. Say here we have 1, here we have 2, right? And if x plus 2 is equal to, say, 1.4, right? So 1.4 lies between 1 and 2. It lies somewhere here. So therefore the value of greatest integer of x plus 2 is equal to greatest integer of 1.4, that is equal to simply 1, right? Okay, now let us take this integral, that is I2. So here we have to assign value to greatest integer of x plus 2. Now here x varies from 0 to 1. So now we can write x greater than or equal to 0, and here we have 1, right? So x lies between 0 and 1. So when x lies between 0 and 1, we need to find the value of greatest integer of x plus 2. So again we can add 2 to this inequality. So we have 0 plus 2, so adding 2 throughout, we have here x plus 2, here we have 1 plus 2, right? So this is 2, this is x plus 2, and this is 3, right? So now in this case we have x plus 2, it lies between 2 and 3, right? So by definition of greatest integer function, the value of greatest integer of x plus 2 is equal to 2, right? And again we can verify it by taking some particular values of x plus 2, and let us take x plus 2 is equal to, say, 2.8, right? So 2.8 lies somewhere here, and the value of greatest integer of x plus 2, that is greatest integer of 2.8, is simply 2, right? So the value of greatest integer of x plus 2 is equal to 2 when x lies between 0 and 1, and the greatest integer of x plus 2 is equal to 1 when x lies between -1 and 0. So now these two integrals can be written as minus. Here we have -1 to 0, and here we have x square dx, and in the denominator we have greatest integer of x plus 2 as 1, so here we have 1 square, right? And the second integral is from 0 to 1. Here we have x square dx, and here greatest integer of x plus 2 is 2, so this is 2 square. So this is minus -1 to 0 x square dx, and here we have 4 taking 4 outside, 1 over 4, and we have 0 to 1 x square dx, right? So now we have two simple integrals to evaluate. So now using the result, that is integral of x raised to n dx is x raised to n plus 1 over n plus 1, where n is not equal to minus 1. So this integral becomes minus, this is x cube over 3 and minus 1 to 0, and here we have 1 over 4 and this is x cube over 3, and limits are from 0 to 1, right? So now I can be written as, taking this 3 outside, we have minus 1 over 3 and x cube and minus 1 to 0, and here we have 4 3s are 12, so we have 1 over 12, and here we have x cube 0 to 1, right? So now substituting the limits, we'll have the expression minus 1 over 3, so here x is 0, so this is 0, minus, here we have minus 1 cube, and minus 1 cube is minus 1, so we have here minus 1, right? And here we have 1 over 12, and x is 1, so we have 1 cube is 1, and 0 cube is 0, right? So this is minus 1 over 3, and this is 0 plus 1, this is 1 over 12, right? And now we can write it as minus 1 over 3 times 1 is minus 1 over 3 plus 1 over 12, right? Now we can simply add these two numbers. So 12 is the LCM, and here we have minus 4, and here we have 1, right? And minus 4 plus 1 is minus 3, and here we have 12, so this is minus 1 over 4, right? So viewers, the value of this integral, which comprises of the modulus function and the greatest integer function, is equal to minus 1 over 4, right? So this is how we solve this important and conceptual integral.